All right. All right, a couple QR codes here if you care. The first one is the app that we're actually going to be deploying with this pipeline and the GitHub repo that goes with it. The second one is the actual repo. I'll put these up at the end as well. But if you want to, there's a little chat app on there. So if you want to join that and chat while we're talking, that's cool too. I'll be able to see them on here. Quickly about me, Jerome introduced me pretty well. I worked at an MSP for a while. I got a lot of experience there, all the way up from like just answering phones on first level support, all the way up to senior network engineer, virtualization engineer. Then I worked at GlobalFoundries doing mostly the same stuff, Active Directory, Citrix, and a whole bunch of other weird things. And then now I'm at Amazon. It's the global security org. It's the physical security for Amazon retail. So like all the warehouses basically we own. Our applications are deployed to obviously in AWS, but for all of the warehouses globally for our team. I personally wrote a full stack app used by the security guards in all of those warehouses that's delivering all of the security events. So if somebody forces a door open somewhere in a warehouse, my app handles that event. The guard looks at it and responds to it accordingly. And so from the actual physical event to the user screen, we shoot for about 3 seconds of latency. And with 20 million physical events per day and 36 million like WebSocket messages basically handled in that stack, all on AWS. And then now I'm working on a project for the actual physical hardware. So I'm really a full stack, doing a Linux deployment with the services running in Rust on that device. I've been programming since 5th grade. I've written everything you see here and probably a bunch more. My claim to fame for a long time was that I wrote my own operating system for a 486 when I was in like, I don't know, 8th grade or something. He gets it. In raw assembly and hex opcode. That's what I was doing after school. All right, so first we're going to start with just an AWS overview. How many people here who have never logged into the AWS console? Okay, just a few. Cool. So AWS is cloud services. I forget what the statistic is, but it's something like 50 or 60% of the internet. It's a lot. It is very well built. The downtime is probably higher than most of the web services, arguably. They do have their issues occasionally. Benefits for it, basically, it's pay as you go. There are a few exceptions to that where they're like monthly, but they're usually pretty low unless you're in some of the really high-end enterprise services. Most everything is pay as you go, and some things are paid down to like the millisecond of use, which comes in handy for applications that are really bursty, or if you're trying to work on a startup, it's a really good way to start up because you can start up very cheaply or sometimes even free. Obviously, global reach, they have data centers in many, many regions. I forget what the total region count is up to now, like 30, 50, somewhere in there. Again, scalability, everything from, the smallest startup with a static web page, which you can basically deploy for free, all the way up to, enterprise applications with just massive, massive scale, Netflix, for example. Secure, compliant, reliable, they're defaults basically especially if you're going through the console and clicking things, everything's kind of secure by default, and you have to really make a mistake or tell it that you want to do something terrible if you want to be insecure. So the defaults there are really good. It has a free tier on several different services, Lambda, ECS, I think CloudFront, and a handful more that allow, again, a small startup or a simple application to be stood up basically for free. Great way to get into this stuff. There's also a free credit for startups up to $100,000 for your startup. So if you have a startup idea, business plan, and an LLC, you can approach them and say, hey, I want to, I'm looking to get credits. And they'll basically credit your account $100,000 and you can do whatever you want with it. First section is compute. So this is the underlying software behind all of AWS, right? Everything runs on top of EC2, basically. EC2 is the hardware in the data centers. And then, EC2 is the way it's represented to the customer as a virtual appliance, virtual box. EC2 itself is basically a full-on server, virtual server, so a Linux server, Windows server, a few other options out there. For containers, you have ECS, which is similar to Docker, also known as Fargate, and then you have EKS, which is Kubernetes like. You have Lambda, which is the, you know, I don't want to call it instant on, but almost instant on serverless architecture where you can run functions, a single function in each Lambda. You get 1 million executions per month for free. Again, that's a huge, huge gain for like a startup because you can get up to, maybe 100 customers for free working on Lambda. And then serverless integrations, I mentioned them here. I'll mention them again during, talking about APIs, but a lot of the services within AWS tie into each other. So like API Gateway, for example, can directly execute a Lambda without having to have a server or anything else in between. Same thing with AppSync. So AppSync can execute Lambdas, execute code on EC2, things like that without having a bunch of steps in the middle. Storage, Amazon has a bunch of options, but these are the main ones. S3 is probably the most common one that people hear. This is where you're going to store websites and media, and if you're storing video or images, that kind of thing. You can make them web accessible. You can make them securely web accessible, where you can sign a token and provide that to the user, where they would have access for 10 seconds, a minute, 24 hours, that kind of thing. It's block storage, yeah. It is block storage. Yep. It's object-based block storage. So similar. EBS is their actual block storage, whereas where you would connect it to Lambda, you can connect it to Fargate containers, you can connect it to ECS containers, and you can share that between different services. So you could have, a Lambda and an EC2 instance have the same, share a same EBS storage. Good for like certain kinds of caching, or if you need you can do a database on there, although I don't recommend it. EFS is Elastic File System, which is more ephemeral. You can attach an EFS to a Lambda or to a container, but it goes away when that Lambda gets destroyed. So you can have a Lambda with 10 gigs of storage, and then when you turn it off, it's gone. Good for file processing, video processing, things like that. S3 Glacier is another step off of S3, but it's slower, much, much slower. It is meant for like long-time archival type stuff. In some cases, it can take 24 hours to get back. So if you go and request it, you actually have to wait for them to go put tapes in, or for the machine to put tapes in to get back. But it's very, very cheap. It's really good if you have a lot of storage. Storage gateway is if you have an enterprise where you want on-prem storage and also cloud storage. This can be a way to merge those together before moving to the cloud or moving back to the enterprise. Databases, I'm not going to go through all of this. We did talk about this on the last week, but I'll go through them real quick. So RDS is like MySQL, Postgres, Oracle, Microsoft SQL. It's Amazon's service that obfuscates the management of those servers. So you can click a couple of buttons and have a SQL server and not have to worry about managing the underlying operating system. It's really nice. The one caveat to that type of database server is that if you have to do upgrades, you have to deal with that. So you have to, move data over, or, that kind of thing. So that's my only caveat there. DynamoDB is the NoSQL storage. It's my favorite recently as far as Amazon stuff. Once you learn how to use it, it's very, very, very fast and extremely scalable to a ridiculous degree. Fully managed database, so you just have an API that you hit, and you can define all of this with code. Aurora is another version of MySQL and Postgres. It's serverless, so when you're not using it, it turns off. So if you're doing, running reports once a week or something like that, that's somewhere that can really come in handy. Or if you just have a bursty demand where maybe, your only demand is between 1 and 3 p.m., that's a really good option for that because it keeps your costs way down. Redshift is data warehousing. So again, long-term storage, lots of data, a lot of big data type of querying in there. Amazon Document DB is basically MongoDB. Again, just a managed version of it. And then Neptune, if you've never heard of it, it's a very different type of a database. It's a graph database. Not super common to use, but if you have a use case for a graph database, it works really well. Networking. So Amazon VPC is basically your own private switch or your own private network inside of Amazon's network. So each VPC will contain all of your resources securely. You can then connect that VPC to the internet. You can choose not to. This would be used for things like connecting a Lambda to an RDS database or connecting, I'm trying to think, a couple of ECS containers together across a couple of regions, that kind of thing. Elastic load balancing. This is just load balancing basically for applications. There's ALB and NLB, and I want to say there's one more. One more. I don't know. Application load balancer is sort of a layer 7 load balancer, so you can use more intelligent balancing of your application. So if you have, you can write rules to do things like move this for traffic from this region to that region. So it's good for like doing maintenance and things like that. NLB is more specifically network, so it's layer 3. Route 53, just DNS, basically. You can also host domains there. CloudFront is where you would host a website. You can do static websites. You can also front end Lambdas that would turn into a website. You could front end a EC2 container and a whole bunch of the Amazon services. Basically can be fronted by CloudFront. And it does a lot of caching and has rules in it and things like that. There's also a thing called Edge Lambdas inside of CloudFront. So you can actually run functions on requests and responses that go through CloudFront, which can come in real handy for like manipulating data as it goes in and out of your website, or tagging different website or different traffic for various reasons. Direct Connect is a dedicated private connection. So if you have a small business all the way up to an enterprise, you can use Direct Connect to connect your business directly to Amazon's network. So you can have your servers up in the Amazon cloud, and it'll basically be like it'll be on site. It's a VPN, more or less. All right. Any questions before I know I'm rattling through these, but there's more important stuff coming. So good. All right. Sure.
So since there's like a lot of things that they offer, and you were talking about like how much you can get for free. I guess like if you start adding many of these services, it will go, the rate will go up very quickly.
There are very specific services that have a free tier.
So no everything.
So it's correct. Yeah. So
There's a full site for it. I can find it on, when we're done here, but
there are services that just aren't free, and there are some that are extremely expensive. So it's just, you really have to be careful. That's one caveat that I will mention towards the end, is just about the pricing and how that works. And some of the safeguards that you can put in place to protect yourself. But yeah, there's only a few specific things, but they're specific enough that it's really good for startups.
yep. For security, we have AWS IAM or IAM. This is basically the underlying security for all of AWS, meaning even within AWS. So you'll have things called roles that have policies on them, and that's attached to, for example, a Lambda. You would attach to a role to this Lambda that then has access to do specific actions within Amazon. So building things in Amazon doesn't mean that this has access to that by default. Again, everything is secure by default. So you have to specifically say, I want this Lambda to be able to access this Dynamo database. And you can be broad and say, I want it to have access to any Dynamo, or, that specific name or a specific index. You can be very granular with it. Probably one of the better services that Amazon has, honestly. Hard to match. Cognito is more the external authentication that you can use for websites. You can use it for even laptop logins and a few other things. But it's a typical SAML provider, just like, I'm trying to think of the name of the one that everybody uses. OAuth. No, what's the name of it? Anyway. But you can use this, and I think it's up to 1 million users for free. It's some ridiculous number. It's another free tier thing. So you can, again, you get your startup up to 1 million users before having to worry about paying for user accounts, which is amazing. KMS is key management service for encryption. So a lot of these services, I won't even try and list them, but a lot of them support encryption either at rest or in transit. And KMS is the key management source for that. And you can choose to either use an Amazon provided key, or you can provide a key that Amazon themselves won't have access to.
Now, one of those where you can set up a 6-month rotation.
Correct. Yeah. Yep. AWS WAF is Web Application Firewall and Shield. The web application firewall works with CloudFront or ALBs, where it manages your website traffic. You can write all kinds of rules in here. There's a bunch of rules already built in. Really good for DDoS protection, malicious payloads. You can really, if you have a well-defined API for your website, you can define exactly what it's allowed to receive and not. And that way, if you do make a mistake on the API somewhere, you're still limiting that beyond your application. It is a little bit pricey, but it's probably worth it. AWS GuardDuty and CloudTrail kind of tied together. They're on the AWS side itself. They do logging and enforcement as far as the AWS account itself. So if somebody goes and makes a change somewhere, it's going to show up in CloudTrail. And then GuardDuty is basically heuristics on that type of thing. And ML, not super well versed on these myself. But SageMaker is for ML models, building and training. Recognition is for any image and video. We do use that internally mostly. Amazon Poly is text to speech. Basically, you get a WAV file or MP3 file. Amazon Lex is Alexa. And then Comprehend is natural language processing for I think originally it was used before LLMs were really popular, but it does a lot of the Alexa type stuff. All right, so this is more the important one because this is where we're going to start to talk about the actual pipeline. So everything in Amazon's ecosystem, 90% of everything in Amazon's ecosystem is able to be defined in code, meaning you can write a lot of code and that becomes infrastructure. This is hugely important for, especially when you start getting into really complicated applications or production released applications where you want consistency. We use it a lot for, and you'll see in the pipeline that I have, where we'll have a beta, a gamma, and a production environment, and they're all very, very similar to each other, right? They have very small differences. And all of that is defined as code, and then with just some slight config changes for each stage of it. CloudFormation is the underlying technology that does that. It's YAML. It's kind of archaic at this point and not too many people use it anymore, but you can go down to the very nitty-gritty layer and define every single individual thing in AWS with that. CDK is a layer on top of that. And this is in many different languages: TypeScript, Python, Java, and I don't know how many more. Those are the ones I know of. But they are, this basically is an obfuscation layer on top of CloudFormation that again lets you define all of this in code. And now it's procedural, right? Because you can write JavaScript, TypeScript, Python to define all of your resources. Correct. Yeah, it compiles from TypeScript to CloudFormation. Yep. And then code pipeline is basically what we're here to talk about today. It is a deployment mechanism that allows you to take from any several different sources. In our case today, it's going to be GitHub, and then deploy that as code all the way through a pipeline. And the entire thing is completely automated. In 2 of the accounts, I have not even logged into the accounts other than to look at logs. So I've not actually deployed anything manually to them. Elastic Beanstalk is simplified app environment for, I think it's mainly for Java. There's a few other things it'll deploy. And then Amplify is another app deployment mechanism that sort of obfuscates this pipeline deployment so you can have different stages and things like that. It's much more of a handhold thing. If you're just playing around with an app or something like that, that's a great way to get started. So you don't have to write an entire package and pipeline and things like that. If you just want to play around and to have a beta and prod environment, they'll get that done for you. So in my little diagram here basically shows like this is the way it used to be, right? Before pipelines were really a thing. And Amazon's had pipelines around for a long time, but not as a service. This is how we used to do things, and they call it configuration management. And you'd have runbooks and documents and configuration files that we kept for each of your different environments, and then you'd have a giant bash script or something that deployed your environment. Scary when you get into a big giant and enterprise level application. Nowadays we have this infrastructure as code, and this is sort of the way it works, where you have your developers pushing into source code, which is then being managed in version control of some sort, Git in this case, and then it's pushed into your CDK, CloudFormation, and then deploy it out to your infrastructure. This is another slide on CDK. And this is an example of what it looks like. So here we have a VPC. It's a network layer, and then ECS cluster. So basically a Docker cluster, and then so this pattern here that they have is an application load balance Fargate service, which basically means you get an application load balancer and a Fargate cluster just with that little bit of code there. So pretty neat. This is kind of how CloudFormation looks from like a logical sense. So you have your app as a whole, right? You have the entire, in this case, in what I'm writing, it's a monorepo. And then we have stacks underneath it. I think I have about 5 stacks, something like that, 6. And then each stack has a bunch of constructs in it, and the constructs have resources in it. And then each of those resources are things like Lambda, SQS, the buckets, that kind of thing. All right. Any questions before we get into the pipeline stuff? Had to keep people awake a little bit. So you have CI and CD, continuous integration and continuous deployment, or oh my God, what's the other word? Delivery. So continuous integration is basically running a process anytime Git source is committed. And then every time that happens, you're continuously building that code into your application. Usually includes automated testing, enforcing coding standards like formatting, linting, that sort of stuff, and then a static code analysis of some sort. And then continuous delivery is automating the release process. So once that code is built, getting that into production, that's the delivery portion. And then you have delivery and deployment. So delivery is more like staging, and then deployment is if you're going directly to production with no human intervention. That's the difference between delivery and deployment. I like delivery. I like to be able to have to click a button before it goes to production because we all know things break. I like to be able to put my eyes on it. But ideally, in a perfect world, you'd have everything perfectly test covered, and you can just deploy it right to production with this pipeline. Yep, and no more deployment runbooks. That's the key there. All of these options. So here's a whole bunch of CI/CD options. AWS Code Pipeline is just one option, and there's probably many more than this. GitHub Actions is a really popular one. Code Pipeline. Jenkins is an old school, but again, very popular one. Google Cloud Build is their version of it. And I forget what Microsoft's is called. Maybe that's the Bitbucket. I don't remember. Super configurable, right? With even especially with Code Pipeline, you have so many options. You can add stages that are completely just a script, just a bash script to do something. So you can really customize whatever you want to do with it. But there's also a whole lot of built-in things you can do with it that I'll show. Infrastructure as code makes it repeatable. So again, you don't have this question of like, well, did he change this, or did who changed this? The code that's in the pipeline is what's in your repo. You try not to push directly to any of your stages other than going through that repository. This kind of thing makes blue-green deployments, or, you have beta, gamma, prod, but some people will also have 2 different sets of prod, or they'll do, a single region or something like that. Pipelines makes that very easy. The zonal or regional canary deployments, where you would, again, deploy it to one server or one region, and then, have alarms to say, okay, this is going fine. So now we can deploy to 2 more regions, and then 10 more regions, and then full, right? You can do all of that in the pipeline. All right, this is the app that we're deploying. That's the QR code for it, if you didn't get it already. Anybody? I've been using this library called Tomagui for my web apps. It provides a obfuscation between it's TypeScript, first of all, and it provides an obfuscation on top of React Native. So you have one language, so to speak, or syntax for all your styling. So basically you get a web app and a iPhone app or Android app all for free, just with one box, which is really nice. So this is nothing super fancy. I just basically took the example and added a chat feature. So it's got some backend API type stuff. Normally you would have authentication here. I don't. See if this works. I just fixed it while we were sitting here. There it goes. All right. So so that pause was probably the Lambda in the back end waking up. So when you haven't used a Lambda in a while, it has to wake up, and they call that a cold start. So you get about a 1 or 2 second delay. So what just happened here is when I opened the page, I hit an API that was API gateway. And then behind that is a Lambda that's written in Rust that basically delivered these messages. The messages are stored in DynamoDB. And then for the real-time messaging, it's WebSocket through API gateway. And again, a Lambda written in Rust. And I think I have a diagram. Okay. Yeah, so here's a little diagram. Pretty sure this is right. I did it a long time ago. Yep. So CloudFront first, that's where the website is. That reaches out to an S3 bucket where the actual, React code is hosted. And then when you first log in or when you first click on the chat page, it's going to go grab the messages from the Rust Lambdas. And then the WebSocket is going to actually, when you send a message, that's going through the REST API to send the message, and then you're getting the messages back through WebSockets. So you can keep that real-time connection. And then the message processor. So when we save a message to DynamoDB, that actually kicks off what they call a DynamoDB stream, which starts a Lambda that then kicks off the web message. Meaning if I go in and just edit the database, that'll do the same thing. That'll actually send a message, and I'll show that in a little bit. This is the first half of the pipeline. I put all of the bells and whistles on here, and honestly, this is kind of what a normal pipeline would look like. But this is just through the end of the beta stage. So I broke it down here. So we have from the source code. So in GitHub, whenever I commit to a specific branch in GitHub, it triggers this whole process. Once that is triggered, it goes to the build stage. We have an ECS container that I've customized, so a Docker, Docker file that builds the whole package. So it's a monorepo. So it goes through and builds the Lambdas, it builds the website, and it builds the tests. Once that's done, it moves to the next stage. This is the self-replication stage or the self-mutate stage that actually updates the pipeline if it needs to be updated. So again, everything is defined in code here, right? When I update, I add a stage to the pipeline, that stage, that step will basically restart the whole process of the pipeline. So it'll change what it needs to change on the tail end of the pipeline and start over. This is the asset stage. It's much longer than this. But this is all of the code for the website. The Lambdas, each individual one is broken down into a specific asset. And that's basically just a packaging thing that AWS does. Then we have what I call zone. It's in Route 53, we have zones, which is a DNS zone. And in this case, it's the Southwest Florida coders.jknott.dev. That deploys out to prod because we need that for the rest of the stages. So when this gets deployed, it'll deploy that DNS record and also some roles, IAM roles that allow beta and prod to use that DNS record from the production account. All 3 stages are completely separate AWS accounts with only very limited access to each other. This is the beta stage. This is where the stacks come in. So each one of these is a stack. So we have a bucket stack, a DNS stack, a monitoring stack, which has alarms in it. We have an API stack, web stack, and then finally the database stack. All of these get deployed in a specific order. You can change the dependency order in CDK if you needed to, but it automatically figures that out to some degree. So when this happens, takes a little bit, but it deploys all of those resources into the AWS account. So if I change the name of a Lambda, if I add a Lambda, things like that, that happens here. It'll actually get deployed into that account. And then at the end of the beta stage, so we have intake tests. So this runs intake tests against the Rust code. So I'm actually running Rust tests that interact with the AWS account in that beta account. So I can do real actions and not just mocked tests. And then I have end-to-end testing. So I'm using Playwright to do end-to-end testing of the website. Right now it just sends a couple of messages, but if you look in the chat room now, you'll see one from Alice. That's Alice right there in the end tests. I guess ChatGPT thought Alice was a good name. And then finally, we have the approval stage. This stage is what defines the difference between delivery and deployment. So this would be a delivery because I'm putting it there, but I'm not actually deploying it all the way until I click that button. That's pretty much the end of that part of it anyway. We can go through the monorepo. What time is it? Sure, how much? Okay, great. Cool.
I have a question.
Shoot.
I've been put down that to utilize code smell, integration testing, how much we could have been tested, or it's just not a lot of we actually use that.
I'm sorry, say the first.
Sorry, you can utilize like code smells.
I haven't. No, we use mostly Jest for TypeScript, Cypress, and I just started using Playwright for it.
Just is for the unit test, right?
You can do intake with it too.
Because I know you
Yeah.
have static, one of the items you show is static analysis.
Yep.
Is that like, so key for security analysis?
Correct. Yep, exactly. Yep. Yeah, so you can add any stage you want in here, you could add something like that, or an LLM to review your code change even. You know, at work, we have a whole list of them. But you know, it gets complicated. But you can really get flexible with it.
And can you do parallel
What's that?
pipelines?
Oh, for sure. Yeah, actually, I don't have both deployed. And a project that I'm working on, I have a dev and a prod pipeline. So I have my dev pipeline is the development branch in GitHub, and that goes out to beta. And then I have a production pipeline that goes from gamma to production. And it's in a different GitHub branch. So I can continue to commit to development, or if I was bringing on a different developer, right, I can give them another branch and a whole other pipeline.
I was really thinking about to say time, for example, because again, sorry, Jenkins. I have one pipeline that's four pipelines.
Yep.
Because I have, for example, develop an app for phones, website and stuff like that. And later on they merge to one pipeline.
Yep.
Can you do that? That's you.
Yeah, you could. Yep. Something that I've seen some people do is basically when it finishes, it then commits the code to a different repository.
Mhm.
So you can have an interim repository or a PR even. PRs could kick off this process and start that and then commit it back to the main repo. Yeah. All right, I will go through the pipeline a little bit so you can we'll get more interactive with it. So not much to see on the source side. Again, this is GitHub, but there are, just infinite options for what you can start. You can have it start off with a Lambda. So if you want to submit through an API, some, line of code or whatever it is, you can start these in any way. The build stage here is, again, an ECS container building through a monorepo. And you're going to see here just all of the build logs, basically. So if you have a problem with your build, you can come in here and troubleshoot it that way. And this is the mutation. So basically all this is doing is building the CDK. So it's TypeScript and Rust. Yep, it's a big monorepo. I'll show you that in a minute. But you can see here, basically the only thing that changed in this pipeline the last time I committed was just the assets. So basically just some code. But it updates all of those assets in CDK. What else would be interesting? Information. All right, so like I said, there's different accounts here. It's hard to see because of the screen sharing thing, but made it worse. Go away. So you can see each of these tabs has a different color. I use this containers plugin, multi-account containers, that allows you to containerize different sets of cookies basically, so you can log into multiple accounts at once. Super handy. They actually do provide it natively now. I think up to 5 accounts you can log into at once. But I like it this way. That way they're colored too. So green is always beta, yellow is always gamma, and red is always prod for me. This is CloudFormation. So this is where my stacks went to. And so each one of these stacks has a bunch of resources in it. So this is our API. And then this is all the resources for that. So we have an SSL certificate. We have the Lambda function that actually runs the code. We have a health check. We have the actual API gateway. And then some of these. So this is the WebSocket connect, disconnect. The API gateway WebSocket API. So each one of these stacks basically represents a grouping of resources that get deployed to AWS. And anytime you change the CDK code, it gets mutated and changed into whatever you need it to be. This is the repo I shared. I'll run through this real quick. If anybody wants a good template for an app, here you go. So basically under apps, we have the whole front end. It's just one package and you get a web React package and an iPhone or an Android app all in one without having to write 2 sets of code. And so you can see in here, those are my 2 tabs. I have the chat tab and I have the main tab. Super simple. I love React Native. It is problematic sometimes with like version matching and stuff like that, but it's been getting better over the last year or 2.
Services host.
What's that?
What is a host?
What's that?
It's like, I mean, like, you know, like when I create just like a free project, I use percent.
Mhm. Mhm.
And they also have like different hosts.
Yeah, yep. So S3, say free. S3 will cost you, but it'll be about 3 cents a month. And you can turn S3 into a static website host and then point Route 53 at it for $1.50 a month. So your whole website is, you know, $2 a month, maybe. Yep. Especially if it's a static site.
So we had a project.
Yep. So there are .NET Lambdas. So you can actually put .NET into a Lambda and only run it when you need to, and you get 1 million invocations per month for free.
You can.
Yeah, come on. Yeah. And as far as like a full-on server, you can have you can have one ECS image for free for I think it's for the first year of your account, something like that. But still, if you can go create a new account, you know, kind of ad hoc and have a free year of server.
It all price.
Yeah, there's a AWS pricing calculator. It's a little complicated. Oh, that's the other thing I wanted to cover that I didn't make a slide for. So pricing as a whole is very, very complicated. There are some things that can definitely get out of hand. The best way to control it is to put a budget reminder in or a budget control in, and I always forget where it is exactly. I think it's in Cost Explorer. Let's see what I paid this month. Yeah, there we go.
That I know what's in.
You put a file in a bucket somewhere. That's what that is. Yeah. They have a new tool in here called it's like resource search or something like that. You can actually find everything that you have in your account now, which was much better than it used to be. Oh, I can't remember where it is. Billing and we don't have to deal with bills too much at work, so I don't look at this stuff too often. But for me, I usually do. All right. Anyway, somewhere in here, there is a budget control where you can control how much. Oh, here it is, right here. So you can set up an alert that basically tells you, you know, you've hit $100 or you've hit whatever your limit may be. If you're in an enterprise, this is so important because, you know, if you're in a startup doing some minor things, you're not going to add up that quickly. But if you're in an enterprise doing some heavy level stuff and all of a sudden you change a line of code and now you have a loop somewhere or you have a Lambda that's triggering another Lambda or something like that, it can get exponential very quick. They are somewhat forgiving once or twice, but not much more than that. But this is the best way to stop it. You can even put the brakes on your account if it gets to a certain point. If you just want to say, hey, this account has a budget of X number of dollars, shut down everything. You can do that. So would highly recommend it if you're developing in there. Here you go.
Really get out of hand is using a SageMaker. That's students that I had available from computer vision project, just having your endpoint live and having it just like a code in SageMaker like that.
Yeah.
That's like the little thing.
How many children have you have?
Yeah. Yeah. The service that I wrote, I think at one point was 90,000 a month. Which that's, internal pricing, but I can't imagine what that would be for the public price. Yeah, correct. I mean, honestly, between TypeScript and Rust, there's not a huge gain, but between like something with Python and Rust, I mean, the gains are like 100 to 1 as far as, if you're running code in a Lambda and you're looking at execution times, because that's what you're getting paid for, that's what you're paying for is how long you ran the thing for. It makes a big difference. Shoot. Yeah. I don't really have a favorite. I mean, these days it's like, which one's better this week? I mean,
There's one that's favorite.
So Grok Code Fast has been excellent with it. I wrote this entire thing with Cursor, and some Warp. If nobody's seen Warp, I can show that too, but this is Cursor.
That's why all my experiments. Grok Code Fast.
Yeah. Were you using it in Cursor though?
Yeah.
Okay.
I'm straight
So-
with it.
One of the things that that Cursor and a few others do really well that matter is source code graphing. So like it knows how to find files really quickly, really easily. So when your repo starts to get really big, I mean, this is a big repo. It's a mono repo of, Rust, TypeScript, it's got a CDK package, it's got intake tests, it's even got an app test. It's a lot, and it's a lot of different things. And I didn't even like make rules for this like I would normally. I just used it raw and it worked amazingly well. But I have used other tools like we use Klein at work, which it works, but I'm not a huge fan of it. It's just nowhere near as good. So having that context of this is my application, this is what I'm doing, and it already has example code and things like that, it makes a huge difference. Highly recommend trying it out. Yeah,
Have Cursor built.
correct. Yep. Yeah, I have a whole slew of them. I will share quickly. Oops. Do that. So I have one for each kind of thing here, and you can basically tag these in to your conversation. And so like when I go to commit something, I run this and it gives me back a bunch of feedback on my code. Like, hey, do this, do that. Even if Vanilla wrote it, I'm still going to do this and it's going to tell me what I should do better. There's also a cursor CL. Correct. And it wrote most of these. I just said, hey, write yourself a rule for, and it writes most of them.
What do you think?
I think it's really good. We just started using one at work. There's two of them actually that we used, and it's really good. Like there is some hallucination, but that's all. There's always hallucination, but that's when the human comes into the loop. I mean, you can usually look at it pretty quickly, especially if you're a developer, and say, this doesn't make sense. It doesn't make sense, but it catches stuff all the time. I mean, just stupid little greater than less than, like all the time. So I really like it, and I mean, I use it for most of my code anyway.
The more explicit you are.
It's a little different at work. So the way it works there is we have a tool called CR tool, and I don't know, it's called Quarks, but we push our code into that and then it gets analyzed.
Oh, okay. Have you used it like GitHub Copilot of yours?
I haven't yet.
It's actually,
It's probably pretty good. I like to go
it's
file
pretty
it in.
good, I think, except when like things are very recent, it tries to give you information that is duplicated. But for most of the time, like it does do a very good job reviewing things because there's things that I miss sometimes.
Yeah.
Yeah.
That's one of the,
I'm just gonna ask you about, do you like WinSurf over Cursor or Cursor?
Cursor over insert. I liked it for a little bit, but they changed their pricing and just made everybody mad. And it cost me about 4 times what I was paying for this in 1 week. And I just stopped using it. So in Cursor, if you use auto, you can see I'm using GPT-5 all day today. But auto here, it's basically unlimited. So, I mean, I've never hit a limit, and I have hit this very hard.
Just thought of that. Yeah.
Correct. And most of the time it's Claude 4, but sometimes it goes to GPT-5 or now Grok. I think it's been hitting Grok code.
Just curious, does it have Qwen 3 code already?
Nope.
That's-
I mean, it's pretty good, especially for a home lab type thing. Like I have it on my local AI too. Okay. I will, so if anybody wants those rules, I'm happy to give them to them so they can see examples. But again, the LLM wrote it based on my project. So I said, here's my project, this is what I'm doing, and write me some rules for it. Where's the other cursor? All right, so just wanted to go over this repo. So the front end code again is just the website portion of it. Front end code, TypeScript, React Native, and Tamagui is the UI framework. And then in packages, we have the backend. This is the Rust package. And then each one of these is a Lambda. This is the CDK package. And this is how I always organize my code. If I'm going to have like more than a couple hundred lines, this has got a little excessive. But if I'm going to have any more than this, I'll create a folder with the stack name and then break it into different constructs. So you can have stack and then multiple constructs. And each construct is basically a class in TypeScript. And then I have the pipeline separated out here. So I have the custom image. This is the build image that I use. You can use the built-in images, but what I found is it's much faster to build your own image in advance with a Docker file. Put all the tools that you need on it, and then when you go to build, it's much faster to go through that process rather than having to install that. They are Docker defined. They're Fargate or ECS, but yeah, more or less, yeah. Yep, it's Amazon's version of Docker basically. But you can see, yeah, it's just a Docker file. And then here's our pipeline. Again, all defined in code. Normally I wouldn't do something quite this excessive with the IAM role, but again, I just shamelessly wrote this with the cursor. So basically just told it to go make me a pipeline, and it did. This is the synth step. So this is where the build happens. You can see these are my build commands here. I try and keep most of the commands inside of the packages themselves. So I just have a build command here. That way it's consistent in my development environment. This is the actual pipeline definition itself. Oops. This is that was one thing I didn't mention. So in AWS, they have a really good tie to Slack. So if you are a Slack user, I like to use it just for personal, it's free. But this is my pipeline notifications. So you can actually see what's happening. So you can probably go back and see a failed one here somewhere. Go back early. I know it failed a bunch early on.
Like the Discord workflow.
Yes.
I probably can connect to
Yep.
Discord.
Yep. So the architecture of this is basically from code pipeline, you configure an SNS topic, which is similar to MQTT if you've ever used that. And then it goes into AWS chatbot, which is installed in here. It's Amazon Q, basically. So that's kind of neat. You can also build buttons in here. So you could, if there's a problem with one of the stages, you can actually build in a button that goes right to the logs. So if you have, a team of developers or something like that, you can set this up so they can just click on that. You can also put CloudWatch alarms in here. So if an alarm goes off in AWS for some service, for some reason, it'll actually pump out the metric with the graph and everything right into Slack, which is kind of a neat integration. And again, all CDK defined. Yeah. Yep. Yep. And that's where that is configured right there. And then you can see here, so this whole chunk is repeatable, right, for every stage that I have.
And so you could do this in multiple pipelines, as you were talking about, or multiple stages. You could split this into many different places where you could say, you know, we have one pipeline that's specifically just to build, and if the build is successful, then it goes to another pipeline. And that way you can have multiple developers working on the same, you know, build process. And that way, if they have a problem with whatever they're building, they don't break other people. This is the end-to-end stage, running Playwright.
That makes it repeatable, so you know each stage is gonna look the same.
Exactly the same. Yep. And even with the same names, the same cases of the names, the logs are the same, like everything is the same. Makes it really nice for troubleshooting. Then we have the end-to-end test here. Again, this is Playwright. Integ, which is just a jest test that is hitting the API. And also using the WebSocket. So it subscribes to the WebSocket, hits the API, does a bunch of testing, make sure everything flows all the way through. And then we have a types package. I like to share types between Rust and TypeScript with its own package. So I have basically all my Rust types that are in the backend are defined here. And then in the then I have a cargo package in Rust that converts all this automatically to TypeScript, which is super handy. So that's pretty much all I got. Any more questions? I'm here for you. So if you have, you know.
Shoot. The simple one first. So I know you showed a little demo with what else does this application do? There's a lot of stuff there.
There is a lot of stuff. There's a lot of, I'll say, boilerplate. I basically did one of every little thing. So there's a lot of example stuff. So like, there's tabs in it, there's WebSockets, there's an API, there's, and then on the back end, you have WebSocket. It's just a very little bit of a lot.
So this was designed to be control.
Well, it's
Whereas you could set one of these templates up and it'll get free.
this whole app sitting in there, the code pipeline is free. The language are basically free unless you run it over a million times. And the cloud front is free unless you know what you want to traffic. And the network free is development. So you guys pay lots of those.
It's not going to go through. There's a lot of answers. Back then, there was no way to save the state. Figured all your lambdas. And you wanted to shut it down, save it, and you load it up again some other day. Couldn't do it. You do that?
Not really, like, there's no way to like shut them down. You can put 100 images in the top down list. But in terms of like you're trying to just code.
I mean, yeah, there's people like a YAML file or something, you can just download and say, here's all my lambda configurations.
Yeah. You can do that. I'll show you.
I used to be able to do that with API gateway.
To export the.
Yeah.
Yeah, and you can do some things with CloudFormation. I haven't done it, but you can import resources now into CloudFormation, and then I think you can export them again. So this is one of the lambdas. You can go up here. Oops, it's down here. You can go download. The SAM file, I believe, has repeatable deployment code in it. Basically, SAM is a local run thing. You can run the Lambda as a local function on your machine. So I believe that has. Do you know for sure? Okay. Okay. Yeah. But anyway, that's why CDK is amazing, right? Because now you can define in just a single JavaScript file what you want the Lambda to be and its code, and deploy that with CDK in one command. And now you have a repeatable thing. You can go and delete it. You can delete the stack and then redeploy it. And it's exactly the same thing that was there. Cloud Development Kit. It's the obfuscation layer on top of CloudFormation, which is their cloud language, basically.
Networks and
Everything basically. It's, yeah, I'll call it 90%. It's almost. Yeah. Yep. Yep.
you can check that out.
Correct.
Yeah, that's, everything is defined in there. Yeah.
Yeah, so you don't have, it's,
Exactly. And then we could put stuff at work, we're gonna have a certain button on team, but a lot of teams that draw account is what they call it, you two people in the office, you'll see the break glass, you actually log into the account. Otherwise, you just, you have to log in. So we can fund this all. That's well, people do, I know it's.
Okay, well, thank you.
Yeah, absolutely.
Thank you, Jane.
Yep.
Okay, so we're kind of early, but we're gonna stay here maybe for about 10 minutes. And then we're all gonna head out. I think most of everybody knows where downtown was. It's like 17, right? After here, we usually, you're coming to? Jason? Yeah, after here, we usually go to downtown House of Pizza. I don't know how wet it is, but if it's very wet, we're gonna eat inside. But if not, we probably sit at the courtyard and that's, we just get looking out there. It's free to hang out here for 10 minutes before we all leave. Thank you.